Hi, my name is Katie Fagan. I am the Director of Training here at Call Dad, and today we're going to be talking about how to read your gauges and get your line temperatures in order to calculate superheat and subcooling. We already have our gauges connected in this video, but if you want to watch a previous video where we show you how to do that correctly, it will be in the description below. So on my gauges, first here, I'm going to be looking at my low side. I'm going to find the PSIG, and I'm going to look at the corresponding saturation temperature. Because this unit is 410A, I'm looking at that pink or rose colored ring, and it's right about 35 degrees. On my high side, I'm right about 250 PSI. And again, if I take that down, I'm going to be looking more at 85 degrees there on our saturation temperature. Now, saturation temperatures are important because that is the point when we are changing state or changing phase. Our refrigerant is either going from a liquid to a vapor or gas, or vice versa, depending on which side of the system we're looking at. So on our high side, this outdoor unit, it is the condenser coil. So we are condensing from a gas to a liquid. On our low side, we are evaporating from a liquid to a gas. So this is the saturation temperature at which that phase change is happening. But that's not the only important number we need. We also want to check our superheat and subcooling. So superheat is any temperature that is above our phase change temperature when we are heating refrigerant. So we've converted everything to a vapor, and the temperature that we add to that, the sensible heat that we add to that, is our superheat. Same thing on our condenser side, our high pressure side. We are removing heat energy, and so everything below our saturation temperature that we've cooled, we've removed that sensible heat, that's what we call subcooling. And it's important to know that we have subcooling and superheat, not only so that the system is working efficiently, but we also want to make sure that we're not damaging any components. So superheat especially is important because we do not want any liquid getting back to our compressor. In subcooling, we want to make sure that we're only getting liquid to our metering device. So in addition to those temperatures, we're also going to need our multimeter. So everybody's multimeter is going to be a little bit different. This is the Fieldpiece SC440. So on our settings here, we're going to be looking for the temperature, so degrees Fahrenheit, degrees Celsius. We're going to turn it so it is in line with that. And you'll notice Fahrenheit, Celsius. Now I also need to come down here and switch it to temperature. And then I'm going to plug my K-type clamp. They are two different sizes, so you want to make sure that you have it in the correct direction. And then when we go ahead and we attach our clamp, our temperature clamp, to the system, okay, again, I'm looking at my low side first, so that corresponds with my suction line or my vapor line. So I'm going to attach it here. We do not want to put on that braze joint, so we may have to scoot down our insulation and put it on here, and then again kind of wiggle it to make sure it is nice and got a good connection. And now you should be seeing those temperatures that we're reading. Right now we are on our suction line, our vapor line, and so it is about 41 degrees Fahrenheit. And I'm going to subtract the saturation temperature here. So that temperature difference is what my superheat is going to equal. On my multimeter, we're reading about 45 degrees, and here we're about 35 degrees. So when I subtract that, I have a superheat around 10 degrees. Next, we're going to talk about the high side. And again, our high side pressures correspond to our liquid line. Again, we're going to move back our insulation. We do not want on the braze joint. We don't really want on the bend either. So we're going to try and find as straight of a portion as we can, kind of wiggle it. I'll make sure it's secure on there. and then get our reading. On this side, what we're going to do is we're going to take our saturation temperature and subtract this line temperature because we're cooling off. So this number should be higher than what is on your multimeter. On my gauges, I'm reading about 85 degrees saturation temperature, and we're about 78 degrees on my line temperature. If I subtract 78 from 85, I've got a subcooling of about 7 degrees. Now, my target, okay, because I do have a TXV on the indoor unit, you would read your data plate. It would tell you what your target subcooling is. In this case here, we're looking at about 10 degrees Fahrenheit, so I'm slightly low on my subcooling at 7, but plus or minus 3 degrees is still generally acceptable. Thank you for tuning in today, and we look forward to seeing you at the next video.